electrolyte capacitor, they have a positive, they have a negative terminal. Keep in mind positive and negative polarity of them. The first step about this capacitor, we just make it as discharge. Might be someone already stored some charge on this capacitor. Someone did some experiment and there is a charge on this capacitor. So first step to remove the charge from the capacitor, to make it neutral, take a small wires and make a closed circuit. Now this is becomes discharge. There is no charge on this capacitor right now. We will do the same thing for other capacitor. Okay, what I am doing? Yes. After few seconds, you suppose there is no charge inside this capacitor. Capacitor charge finished. Both are empty right now. This is a DMM. This way we are going to use differently. Look here, this is a common always, negative, common always. And this is the terminal here in the bottom, on the left side of the common. This is milliampere, you can see in the down milliampere. But this time you will see on the left side of the selector, there is a microfarad. So in my table, there are 4.7, there is 10 microfarad approximately. So we can select a scale. Look here, 200 microfarad, 20 microfarad, 2 microfarad. So the best scale is 20 because my values are under the 20. Don't need 200. This is so enough high. Turn on this power supply. You can select any one. This is the C1. Suppose this is a smaller number. I put this as a C1. Positive, always with positive. Keep in mind, this is the positive here, this is the negative. And see what value is there. 6. No, this is C1, my smaller value. Look here, this is smaller, 4.7 written, but the here value is 3.13. 3.13. So now just please, this is the two capacitors. There are two capacitors. We will take parallel and series, same like as resistor. First of all, we will discuss parallel. Number 2. What did you know the second time? You find its value with the help of DMM. So in my case, C1 is 3.13 microfarad. And now I will find capacitance of the other capacitor. Negative with the negative, positive with the positive. Its value is 6.87. C2 6.87 microfarad from DMM. It's okay? These values are coming from DMM. These are the real values. Number 3. Make a parallel circuit without battery. Without connected with the battery, you make a parallel combinations. Look here, positive with the positive, negative with the negative, and take 2 more wires. Positive here, negative is there. Look here, these are parallel combinations. Find again what is this equivalent capacitance of this combined two capacitor. Positive with milliampere, negative with common, and you will see 9.98, 9.99. So number 4, equivalent capacitance here. C equivalent P 9.98 microfarad. From where? Again DMM. It's okay? Now you prepare your battery for 5 volt. Normally we use our battery for 5 volt. Just make it connection. Please connect it. Not micro now. You must change to the voltage right now. 20 volt is good. Increase voltage up to 5 volt. Five volt. So this is the 5. Where are the terminals? Common and the right side voltage, and range selector will be on 20 volt. Now this is a 5, you can see. Remove this, don't disturb this power now. Remain 5 volt for all our experiments. Right now you connect this power supply with our parallel circuit. Positive with positive, negative with negative. What is the next now? Number 5. Set 5 volt battery and then connect it to the circuit. Number 6. What is the voltage of battery? 5 volts. Now we are going to find voltage on C1 and C2. Do you remember, if the circuits in parallel combination, voltage remain same. So if you take another 2 wires, positive on the right side, common, and here's my C1. I will check positive with the positive. It should be 5. You will see here 5. So V1 is equal to 5. How do you think about V2? It should be 5. But you have to be confirmed. Remove wires, put here, and just check one time. Yes, it's 5. V2 is also 5. Do you remember this basic formula? Q is equal to CV. This is for capacitor. Keep in mind. Now you have a voltage, you have a capacitance C1, C2. Can you find Q1 and Q2?
Yes.
From the top formula? Q1 is equal to C1 V. No V1, V2, because they are same values. What is C1? 3.313 times 10 to minus 6. Don't forget this number. Then multiply with 5. I will give you one, make a more simple life. Don't write this 10 to minus 6 in your calculator. Just multiply 3.15 with the 5. You will have 3 here, 15, 1, 5, 6, and 5 to the 15. This remain there. Don't see. Don't remove this one. If you put in your calculator, you will get here answer minus 5. Might be confused, because in our all calculation we always use micro. So this is a micro. So keep it as a micro. In micro coulomb. Same we will do here Q2. C2V 6.87 micro into time 5. There will be some answer with coulomb. Micro should be there. And there are some numbers. Do you remember in parallel combination, if you have some money here and there, what total money belongs to you? Q1 plus Q2. So the total charge will be equal to Q total will be equal to Q1 plus Q2. So here some answer must be coulomb, 10 micro coulomb, and here some numbers. Just add this number with that number. You have total charge on combined circuit, and you have a total voltage on combined circuit, that is a combined power supply battery voltage. How we can get the capacitance right now? 9 capacitance C, we can write here C equivalent experimental. What is the formula? So how we can find the C right now? Q over V. Total Q over total V. This number put here. Here will be the 5. You will get some number micro and farad. This is your experimental value. You can write here experimental value. Number 10. Do you remember theory formula from theory? If two capacitors are in parallel, how we can get the answer? C equivalent theory. Yes. So some simple in parallel combination. What is 3.13 microfarad plus 6.87 microfarad? Add together. Microfarad. This is your experiment accepted value. Theory. Approximately, yes. And then finally you will do percent error. You will enjoy this experiment because there is no graph. It's so simple. This is all calculation for parallel. I am doing now for series. All steps will be repeated. Nothing new. What is the now for series combination? Series combination. What was the first step? Who will tell me please? First of all, discharge your capacitor, make it empty. Remove all wires. Yes, all wires are here. This is my first step. This is repetition, nothing new. What happened now with this capacitor? It becomes empty. Same here. Both are empty. The first step finished. Discharge capacitor. What is the next step now? Find out again their capacitance with the help of DMM. DMM for capacitance is 20 microfarad. This comes here. And this is my first capacitor. Positive, negative. It should be close, but thought a little bit change. 3.17. 3.17 microfarad. This is our C1. C2. What is C2? .96. 6.96 from DMM. It's okay. What is now third step? Third step, make a series circuit. How we can make a series circuit? Look here, positive of the one capacitor joined with the negative of the other. And now we need two wires. Positives here, negative there. How do you think now? Series. This is series, okay? This is series circuit. And now find third finish. Series circuit. And we are not connected with battery. Not complete circuit, we just make you two capacitors series. Find its capacitance, equivalent capacitance. Look here. This is capacitance, not voltage, common. Red towards a milliampere. And it should be 20 microfarad. This is 2.18. C equivalent series, number 4 steps. 2. How much answer? 2.18. From where? DMM. From DMM. This is a repetition. All. Number 5. Make 5 volt battery. 5 volt. Number 6. Find voltage now. How do you think now in series circuit? It will be change. How change? Look here. If capacitor is in the series, charges should be same. Should be same. If Q must be the same, how do you think if C is less? What do you think about V? If C is less, it will be high. Correct? So now they are different. On smaller capacitor, voltage should be high. Voltage. Change it to the voltage now selector. 20 volt. Positive on the right side. Common negative. This is my C1 smaller capacitor. Here voltage will be high. Look here, what is the value here? 3.42. One thing very important here. You just put one time and see the value. If you stay there, voltage coming down. Why? Because now charge is going to discharge via this DMM. So don't wait, don't talk anything, and don't think anything. Just put one time for voltage. Put, see, and write down. You don't have extra time to make some joke or send some talking or think something. Immediately after putting the terminal, see the value, write down on your paper. What was value here? 3 point. Okay, I will check again. Here, one thing here. 3.54, I think. We will see. Voltage. This time we are going to find voltage, not capacitor. 3.37. 3.37 is the V1. V is a 5. Capital V remain 5. This is the battery voltage. C1 is equal to 3.37. Yes. And this is smaller capacitor. Did you notice here? On smaller capacitors, voltage is high. This is V1. And this is V2 now, right now. On bigger capacitor, remove this part from here. Positive with the positive. This is the down, see, bottom. This is a positive. Clear? So, sometimes you use the same color wire and you might be confused with the wire. See the terminal of the capacitor. This is a negative, black. Positive here. 1.65. Quickly. 1.65. 65 volt. What is the number 7 now? It should be Q1, Q2 equal, but this is theoretically. And practically there is some error. There are some mistakes. So you have to find Q1, Q2 in the same way. C1, V1, Q2, C2, V2. What is C1? 3.17 micro into this one. 3.37. You will get some answer here, -6. This is a coulomb. Same here, 6.96 micro, 1.65 volt and farad here. You can write all together 10 to -6 coulomb. Okay, I told you before, here in the series circuit, it should be same. But we are doing experiment, we have some error. Values are not same. So what do you think? If there are two values not same and we are expecting they are same, what should we do? We take their average. We take their average. Don't add Q1, Q2 now. Q1, Q2 addition here in parallel, in series, just take their average. Number 8. Q average. Q what is Q1 plus Q2 over 2. And how we can find the capacitance now? Can you find the capacitance? You have a total overall charge and you have an overall voltage. You can find C equivalent experimental Q Average our total V. 5. You will see some answer microfarad. This is your experimental value. And number 10, what is the formula for series capacitance?
1 by C.
Series, huh?
1 by C.
We can write here and we can write here experiment equivalent theory C1 times C2 over C1 plus C2. You are also right. But if there are two capacitors, we can write this formula. Put these values here 3.17, 6.9896, then 3.17 plus 6.96 all together get here in microfarad. What is the last step? You know. This is your theory. We can say that it is accepted value. It's okay? What is the last step now?
Percentage error.
Percent error 11%. Error, you know this formula, A minus A over A times 100. You will enjoy this experiment. This is so simple. Maybe I fill all the whiteboard, but actually this is the one part. I do again the same steps. So simple and no graph. Go ahead please, I will come and see you.